Okay, in this lecture, we're going to look at the stack exercise. This code is written by one of my good students, Martin. Hi, Martin. Thanks for sending your code. You've done a really good job. I'm just going to tweak a couple of things here to remove the bug that you told me about and make the code a little bit cleaner. So basically, the bug that we have in this program is if we start pushing numbers from 0 to 5 to the stack and then popping them, the program works. But if we start from 1, it doesn't. Let's give it a try. So let's start from 0 to 5. So as you see, numbers 5 to 0 are popped from the stack. So the program is working properly. But if you change this to 1, let's see what happens. So instead of getting 5, 4, 3, 2, 1, 0, we got 5, 3, 2, 1, 1. What's going on here? Let's take a look at Martin's implementation of stack. So here is how Martin has implemented stack. He has a private list of objects, which is really good. So we're using object here to make sure we can store any object in the stack because object is the parent of all classes in .NET. So well done, Martin. In the push method, here we check if the object that is being passed is null. And if that's the case, we throw an exception. Really good. Now here is some logic for adding that object to the stack. We're going to explore this in a few seconds. And here we have a pop method. So first we check if the stack is empty, then we do not allow the client of this class to pop any objects. So we throw an invalid operation exception. Really good. And here is the logic for removing the object and returning it. Now, why do you have this bug in this class? Well, what I see happening here is first, we add that object in the list. And then I'm guessing with this logic, we're trying to move the objects in the list one to the right. I don't think this is really necessary. All you need to do is to add that object to the end of the list. So I think this code is really not required. So I'm going to delete this. So with this code, we simply add that object to the end of the list. Similarly, let's take a look at the pop method. So here we get a reference to the object that we should return. And then we move items in the list, one to the left or one to the right. I'm not quite sure what's happening here. And then finally, we remove that object from the list. Again, I think this code is really not necessary. We don't need to move objects in the list. So I'll delete this. Instead of the remove method, I'm going to use remove at. Remove at gets an index. So remove at. Now, what is the index of the object that we want to pop? That's the last item in the list, right? So that's going to be list.count -1. Here we have -1 because the index of the first item in the list is 0. We also need to change this. So the object that we want to return is the last item in the list. Again, list.count -1. Now I want to add a vertical line break here. Because when lines are close together, that means they're related. When I first saw this code, I thought all these 3 lines together represent one concept, but that's not the case. Only this if and here the throw exception are related. Another thing we can do to improve this code is we have repeated this list.count -1 twice. So we can extract that into a variable. So what I'm going to do with ReSharper, Control-Shift-R, introduce variable. And I'm going to replace 2 occurrences. So we just call it index. So that's the index of the object that we want to remove and return. Also, instead of using int, we can use var. And similarly, instead of object, we can use var. Now note that the naming convention for local variables in C# is camel notation, which means the first letter of the first word should be lowercase. Also, ReSharper is suggesting that here, so take a look at this icon here. We can activate that by pressing Alt and Enter. ReSharper is suggesting to rename it to match the standard naming convention. So I'm going to go ahead with that. Okay, I think we're done with this method. There's nothing else we want to do in the add method. So far, so good. I see a green underline here. And that's because ReSharper is suggesting to make this list read-only. The reason for that is we don't want to accidentally reinitialize that list anywhere else in this class. So I'm going to put the cursor here. Alt and enter with ReSharper. Now the stack class is finished. Now let's run the application. So note that the bug is fixed. We get 54321. And if I change this to 0 to 5, it still works. 543210. Is there anything else we can do to make this code better? Well, we can change this stack here to var, because look, it's already repeated here. So it's obvious that it's of type stack. So I put the cursor here, Alt and enter. Note that underline is used to prefix private fields in a class, and we shouldn't use it in naming our local variables. And if you note this icon here, even ReSharper is suggesting that. So with ReSharper, Alt and enter. There is one last thing that we need to add to the stack class that was part of the exercise requirements, and that's the clear method, which removes all objects in the stack. So I'm going to go here, public void clear. All we do is to call the clear method of our list that internally represents the objects in the stack. Now we can test that. So here we push 5 objects in the stack. Now we clear the stack. And when we get here, we should get an exception because the stack is empty and we cannot pop anything. So let's run the application. There you go. We got an exception of type invalid operation exception. That's it. Again, Martin, thanks for sending me your code. I hope you enjoyed this video and learned something from it. Thank you for watching.